All right, so our objective today, oops, is to understand scientific notation and standard form of large numbers. So for the majority of you with your project, these are the numbers that you found yesterday, so now you'll have the idea of how to write the number both directions, okay? So first thing we want to do is write down our definition of scientific notation, so that we have it handy. So scientific notation what do you think scientific refers to? What do you think scientific refers to? Jacob?
It involves like science?
It involves science. Again, this was a strategy that scientists use because scientists are faced with very, very large numbers and very, very small numbers. And in order for them to, like he was saying, instead of having all these zeros and making a lot of mess on a paper or trying to communicate with people, it is far simpler to do it in this kind of abbreviated fashion. Okay? So scientific notation is a method of expressing very large and very small numbers as a product of a number greater than or equal to, so it could be, oops, that didn't work out right, sorry. One, but less than 10. So in other words, you can only have a number in the ones column. You can have other numbers in the 10 decimal places. And a power of 10. So again, it's going to look something like this. And I do use the X symbol for multiplication. Aaron, you writing this down? I do use the X symbol for multiplication in scientific notation. You don't see the dot, and the reason is you have a decimal often in your front number, and so people get confused, is that another decimal point or is that a multiplication symbol? So we have 1 point, 1 dot that represents a decimal, and then the next thing you'll see is the old-fashioned X for the multiplication. Okay? So again, today we're going to look at large numbers. Tomorrow we'll look at small numbers, and then on Thursday we'll review the two and practice them again. Okay. For those of you going on the marine biology trip, I should have everything organized for you by tomorrow. Okay. And you can look ahead in the book. And the one thing you'll miss out on is we will be posting these videos up. So when you're at Catalina, you may not be able to watch those unless you pull them up on your phone. I don't know what your rules are going to be regarding things like that. So you may have to wait till you come back to watch the videos if you're confused about something. But what you can do, and what I may do as well, is I may just make copies of the book pages so that you can take those as well. Okay? All right, so today we're going to talk about large numbers. And large numbers are going to give us a positive exponent. So that's a key idea to keep together. So let's go back to that example that we had where we had 250,000 and we wanted to write it in scientific notation. So what I'm going to do is I'm going to take my decimal point, which when I don't see it, it just means it's after the ones, and I'm going to move it left until I have a number that's between 1 and 10. So I move it once, twice, 3 times, 4 times, 5 times, and that's where it rests between the 2 and the 5. So the number portion of my scientific notation is 2.5. Then I write the multiplication symbol, and basically I would be multiplying by 10 to the 5th power. Now where does that 10 to the 5th power come from? So remember what they kind of talked about in that step-by-step. They said take the original number, divided by the decimal that you get. And see what you get left behind. So move the decimal over once, move it over once, put in a 0, and then this is where the decimal point belongs. So 25 goes into itself once, and then I have 1, 2, 3, 4, 5 zeros left over. So that's where this notion of to the 5th power comes from. Okay? So, step by step, we are going to go to write in scientific notation. We're going to move the decimal left until the value is between 1 and 10. Now, mathematically, when we use the word between, normally it doesn't include the two numbers, but in our case, we can have a number in front that's just a 1, but we cannot get all the way up to 10. Okay, so we'll not include 10. So we move the decimal left until the value is between 1 and 10. Okay, now when you write the number, you're going to write the value without the zeros. Remember, Jacob didn't say it's 2.50000. He just said it's 2.5. Okay, so write the value without the zeros. Multiply. And in parentheses, I'm going to put the X symbol to remind you that's what you're going to see. By a power of 10. And remember, we talked about powers just means exponent. Okay, and let's talk about where that exponent comes from. N, which is the exponent, is the number of places the decimal moved right. Move left, sorry, move left. Okay, so we move the decimal 5 places to the left. That's the 5 that goes in the number as the power number, okay? So let's do a couple that go from that direction, and then we'll talk about, well, how do you take scientific notation and write it back into standard form, and we'll talk about what is exactly standard form, okay? All right, does everybody have this?
No.
Okay, all right. Okay, so let's do a couple of examples. The directions are going to say something along the lines of write each in scientific notation. Oops, hate it when when I do that. Let me rewrite my n. So write each in scientific notation. So one of the numbers that he mentioned in the video was the distance from the Earth to the Sun, and that's estimated at 93 million miles. So, Connor, when I move my decimal point and I stop, what number am I going to end with for my scientific notation?
9.3.
Excellent. So I'm going to get 9.3. Okay. The next piece says I have to multiply by some power of 10. Joey,
Yes.
what power of 10 am I multiplying by? In other words, how many places did I move the decimal point?
7.
Moved it 7. And here's your verification. 1, 2, 3, 4, 5, 6, 7. And there's your answer. Bam, done. Okay. Now, we got to ask the question, so let's ask it again. I moved it 7 spots, but there were only 6 zeros. And I was very observant of Isabel to ask that question. Why did it go 7 and not 6? Okay. Sophia.
If it went 6, it'd be 93.
Yeah, if I stopped with just the zeros, it would take me to 93, which doesn't meet the first criteria that it has to be between 1 and 10. Okay? All right, let's do another one. Do you guys remember doing this last year?
Yeah.
Okay, interestingly enough, I gave a quiz to the Math 8A kids, and virtually nobody got this right. So for some reason, that didn't seem to really log into their brains. Giovanni.
Is the homework's going to be on tonight just this?
Yeah.
Wait, does that mean
There's no way to solve it yet. You have to follow a set of directions. So this is our first set of directions. So Giovanni, since you opened your mouth, I'm going to let you give us the answer to this one. What do you think how I would write 6400 in scientific notation?
6.4.
6.4. That's not the only part of it. We need this part too. Alex, how many places will you move the decimal point to make it 6.4?
2.
Careful. If I did 2, it would stop me here and I'd have 64.
3.
Yeah, I have to go one more spot to get around. So the answer is 6.4 times 10 cubed. Okay? So basically that's the kind of stuff that you guys are going to work on tonight. Now notice that I'm not dropping. Let's do one more. I'm going to give you a ridiculous one.
That's ridiculous.
Yep. This is a light year is the distance that light travels in 1 year, and it's equivalent to so let's see, we've got ones, thousands, millions, billions, trillions. 9,461,000,000,000 kilometers. That's how far light can travel in 1 year. Okay? That's pretty amazing. Now, David, what would be the decimal part to this answer?
9.46.
Notice that all the non-zero numbers stay. Okay? Now, Taylor W., what power of 10 is that?
12.
Very good. Now, there's a couple ways to do it. You can do this. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can count it up that way. Or recognize this. There's 3 numbers in this grouping, 3 numbers in this grouping, 3 numbers in this grouping, and 3 numbers in this grouping for a total of 12. So you've got 2 ways to kind of think about how to get that number. Okay? Wow, that's a ridiculously large number. All right, so let's go the other direction. Let's talk about standard form. And that's simply a number written with no power of 10. So again, we're just going to focus in on positive exponents today. Tomorrow we'll talk about negative exponents. So here's our example. What if we have 3.5 times 10 to the 6th? And we want to write this in standard form. Okay, so think about the action we took to write a number in scientific notation. If we want to go to standard form, we're just going the opposite direction. Okay? Cameron, what do you think? You got your hand up.
So you put 3,
Okay,
so 35,
so you're saying we've got a 35.
and then you put 6 zeros then.
1, 2, 3, 4, 5, 6. Okay?
But then you put columns between them.
All right. Anybody agree or disagree with that answer? Okay, Giovanni?
Yeah, add a little more zero.
So you think it needs one more zero? 1, 2, 3, 4, 5, 6, 7.
You stretch me out, sorry.
Okay, so we have this idea. Taylor B? Okay, from which one? From the first one. Okay, so 1, 2, 3, 4, 5. Okay, wow. Okay, so let's figure out who's right. All we need to do is this. Take our number. That's the ugliest color ever. And we're going to move the decimal point to the right. It looks like baby poop, I'm so sorry to say. 1, 2, 3, 4, 5, 6. And we're going to fill up all these blanks with zeros. So let's see. Oh, that seems to be the right answer. Very good, Miss B. Okay. So again, this is the best way to do it, is just make the motions. Go around. And what happened is people forgot about going around the 5. That's one decimal place that we moved. So the answer is 3,500,000. Okay? So let's write down the steps that we took. Because the exponent is positive, let's write that piece. We're going to move to the right. Positive and right, good. Escribe, por favor. Because the exponent is positive, we're going to move, I should say, the decimal to the right as many places as the exponent tells us to. And then we're going to fill any blanks with zeros. Okay? So that's standard form. It's a number written with no power of 10. We're going to move the decimal point to the right because it's positive. We're going to move to the right as many places as the exponent tells us. Any blank spots are going to get filled up with zeros. Okay? So let's do a couple of examples of this one. Directions here are going to... Oh, what, we not done? Okay, so let's just do a couple of examples. The directions are going to say, write each number in standard form. So this is the inverse of scientific notation. Okay. So let's do first, oh, sorry, what are we at? Number 4? Example 4? Yeah? Is that right? We've done 1, 2, 3? Okay. So 7.034. Notice that there is a 0 here, but that's because he's between two non-zeros. Between two non-zeros. Aaron, you got it right, babe. So, on your paper, see if you can come up with the answer, and then raise your hand if you think you got the answer. So 7.034 times 10 to the 9th, or 7 and 34 thousandths times 10 to the 9th. Standard form says you're going to move the decimal point so that there's no times 10 to the something power. So yeah, you'll see a bunch of zeros with standard form, okay? We got a one-man show with Giovanni today, so I'm going to call on Summer. Shh.
So I say the answer.
Tell me what to write, and we'll check to see if you're right.
7.03 0, comma 0, 0, 0, comma 0, 0, 0.
Okay, ooh, I think I see a problem with that one. What's the problem here?
Oh, I put this comma in.
Oh, Kina? What's the problem?
There's too many numbers.
Okay, so something is wrong with the numbers. There's another even bigger problem, though. Okay, Joe?
Well, she put the comma in there, but there's only supposed to be 6 zeros after the 4.
Okay, so we have an issue with too many zeros, but there's an even bigger problem, Mark.
The decimal.
There's still a decimal. The whole point to standard form is to get rid of the decimal. So let's try this one again. Silly you indeed. Okay. Kina, what did you get?
7, comma 0, 3, 4, and then 6, and then 0, 0, 0, 0, 0, 0, and then another 3 zeros. Okay, so there's a comma.
Okay. Ooh. I think we may have a little bit of an issue with this one. I think we may have a bit of a problem. Okay. Connor, what's the problem with this answer?
There's too many zeros.
There's too many zeros. So, yeah, because I'm supposed to move the decimal point. How many places does it take me to move the decimal point around all the digits that are already there?
3.
Takes 3. So that's 3 of the 9 places, right? So, Connor, what do you think the real answer should be?
7, comma 0, 3, 4, comma 0, 0, 0, comma 0, 0, 0.
Okay, now, here's how you can test if he's right or not. I don't know, so all you do is take the decimal point and physically 1, 2, 3, 4, 5, 6, 7, 8, 9 places. Fill up the blanks. And there were 6 spots that I had to fill up. So that's where those answers go. So think about it. I had 9 as my exponent. It took me 3 digits to get around the ones that were there. That left me with 6 zeros. So that's a way to think about how to get the answer.
So this is our project. We have to do that.
Yes, this is what you're going to be doing with your project, is writing the number both ways. One with all the zeros, one without the zeros, but using times 10 to the something power. Okay, let's do one more. Let's do one more. No. No! I know, really. Give me a heart attack. Okay. Aaron, I noticed you're not writing, buddy. You had your hand up but didn't get called on. So, what do you think the answer to this one is? You can do it on your paper first. Like that? Okay. All right.
Where?
236,000. Sydney, do you think he's right?
Yeah.
Okay. Why?
Took away the decimal from 2.3.
Okay. But how many places did I move?
None.
Oh, no, you don't just pull something away. We're moving the decimal point because that's what multiplication says. We get to move the decimal point right. But we just don't end at 236. How many places did it tell us to move the decimal point?
5.
Okay, I'm talking to Sydney.
Oh, sorry.
It says right there, I'm going to move it 5 spots. How many spots have I moved it so far?
3.
How many spots have I moved it so far? Pardon me? Yeah, I've only moved it around the 3 and the 6. So how many more spaces do I need to move it? That's how I get my exponent. Okay? Hood off.
Sorry.
So, Aaron, very good. You had the right answer. Okay?